Hey, check this out. You've probably seen one of these before, and I imagine you don't think this is terribly impressive, but watch this. Aha, magic. Now you've probably seen something like that before also, and that's also not impressive. But, like, where does electricity come from, man? And that's a good question. I'll show you. Here's an analogy. It's really not the greatest, but it works well enough. So electricity is just kind of like water. It's already there, and the magic happens with getting it to go from one place to another. Now, when I say one place to another, that basically means from one terminal to the other. And we can do this in a variety of ways by sticking these little plugs in there, which go to something, at which point the electricity goes out the other side. Again, I'm using loose terminology, and it's a little bit more complicated than that. But I think this is good enough for now. Now, if you're living in a first world country like me, you are most likely vaguely aware that electricity is generated at some power station somewhere, and it gets to your domicile somehow, and you really don't kind of think about it. But let's suppose you didn't have someone generating that power for you. What would you do then? Well, you could generate your own power. Okay, so here I've got an assortment of equipment. Over there I've got some cables, I'll get to that in a minute. And here I've got an inverter. Now what this does is it plugs into your car's outlet. It then converts the DC, which is usually about 12 volts, of your car battery. It turns it into an AC signal through a process of inverting, hence why this is called an inverter. It then turns that into your typical wall outlet power that you can plug some stuff into. And I say some stuff because this unit is capable of turning only so much electricity into wall power. And this is indicated by the wattage rating. Here I can see it's capable of 200 watts, which is kind of like the electrical version of horsepower. It's capable of delivering 200 watts continuously or 400 watts in brief intervals. Here you can just see some general numbers as far as how things are going to get connected up. There you've got the input, which like I said is for 10 to 16 volts DC, or 12 volts typically. And that's going to get outputted as 120 volts of AC voltage. Over here I've got some tools. If you're wondering as to whether or not your outlet has been disconnected and is carrying any sort of hidden electricity, you can use one of these voltage detectors. It just runs off batteries. And these things are cheap enough. However, I would suggest going for a basic multimeter. And unless you're doing some kind of specific electrical activity, this is going to probably cover at 90% of everything you'll ever do. Okay, here I've got my car battery. This is my actual battery that I just pulled out of my car. I think I'll go ahead and measure this since I can, just to generally demonstrate how you use one of these. First off, I'm going to turn it on. So we've got some numbers. I'm going to set it to DC voltage and make sure my leads, my cables, are plugged into the right spot down here. Here I've got my common or ground, and I'm measuring voltage. Okay, so I'll just take these. I'll make sure black goes to negative and red goes to positive. So just think of like temperature, I guess. So if something's red, it's usually hot or high temperature, or high voltage. And something's black, it's usually cold or low temperature, voltage, whatever. That's what I use to help me remember. So touch black to negative, red to positive, and here you can see, yes, this battery is charged. What I'm going to do is connect this power source to this power converter, and I'm going to use it to charge some headphones. Now you may look at this and wonder which color goes to what spot. To figure that out, I just used this multimeter in my car's outlet, and I determined that this center part, this tip, is where the 12 volts goes, and this side, or the sleeve, is where ground is, or 0 volts. So in engineering terminology, we call this a tip sleeve setup. And if you ever used a pair of wired headphones, that's known as a tip ring sleeve setup. Go ahead, take a look. I went ahead and attached some leads to these two terminals on the batteries. And here you can see they connect down to my multimeter, which is reading 12.8 volts. And that means I have a good connection. I imagine there's some people watching this that are wondering if this is dangerous. And actually, no, it's not. Well, not in the traditional way you might think. If I were to touch these two leads together, these ones right here, I would get a short circuit and probably start smoking some things. However, this voltage is too low to be dangerous for my human skin. The reason for that is the resistance of the human body. It's much higher than a typical piece of wire, and that means that I'm not going to get a whole lot of current going through my body and causing me any sort of harm. Now, you're probably familiar with some kind of phrase of, it's not the volts, it's the amps. That's kind of misleading because it's a complicated interrelationship of numbers, and you really should get more educated on the subject rather than going off some kind of cliche phrase. Anyway, that's my rant. My leads are connected, everything looks good. I think I'm getting power to my unit, so I'll go ahead and plug in my headphones and hopefully they don't blow up. And there we go. My Bluetooth headphones are charging. Just to show you that this is actually charging, I'll go ahead and unplug it. You should see this little LED turn off. Yep. Go plug it back in again. All right, cool. So there you go. We have just generated electricity. Now, I don't really mean that literally, because we already had the electricity generated from the alternator in the car, and it's really just been stored in this big box. All we're doing right now is just transforming it from one type to another. If you genuinely did want to generate electricity, that is possible. You could use something like this solar panel right here, which, as you can see, plugs into a 12-volt system. So the idea would be is that this would collect sunshine. It would then route this electricity into your car battery, which would store it. Your car battery would then distribute the electricity to any sort of drain or endpoint through whatever sort of converter that you want to do. And then you would just use it however you wanted. If you didn't want to use a solar panel, you could use some kind of mechanical generation, like a generator or an alternator. Now, it is possible to rig up something like that out of a typical motor, but that's a little bit more of an advanced idea, and I'll leave that to you to do some research on with better videos that have already been made. Now, if you remember, I showed you these other two outlets on the front of this inverter. And this could also be a way of providing electricity to something else, such as your actual house. This goes back to the cables that I showed you earlier. And this process of putting electricity into your outlet is called backfeeding. Backfeeding is pretty dangerous, even if you do have experience working with electricity. So I'm kind of hesitant to do that. One of the main concerns that I have is not only will you be holding live voltage in your hand when you're plugging in this cable, but you'll also be fighting with the power company who is also generating electricity. And if your power and their power mix, something's going to blow up. If you do ever feel brave enough or desperate enough to pump electricity into your outlet and therefore the rest of your house wiring, make sure that your breaker is separated and turned off and that your house is disconnected from the main power grid. Because again, if your house network of electrical wiring is still connected to a power supplier and you try to pump electricity into it, you're going to get electricity forced back out at you and you will cause a fire. So please be very careful about whatever sort of things you do to play with electricity. Other than that, good luck.